Good morning. We're just going to talk about the quadratic formula. This is not going to be a proof of the quadratic formula. We're just going to use it. The big idea is that we can calculate x if and only if, that's what this double F thing is, if we have the equation set up like this, ax squared plus bx plus c equals 0. If we have that as a setup, then we can solve a quadratic formulas or quadratic equations using what's called the quadratic formula, which is this complicated looking thing up here. I kind of goofed up here. This should be equal 0. So if I want to find the zeros or find the solutions of any equation, well, I got to set it equal to 0. And then I look at it and I go, hey, look, I've got this already set up in that form. So I'm going to just make some notes for myself. I'm going to write down a equals 1 because that's what the coefficient here should be. B is positive 5 because that's the coefficient here. And C equals negative 20 because that is the constant at the end, just like our A, B, and C. So we've done stuff like this when we talked about H and K and trying to figure out what those, trying to find the vertex. Anyway, so now I'm going to start by plugging into the quadratic equation. So the quadratic equation says the opposite of b. Well, the opposite of b is negative 5 plus or minus radical b squared. I'm not going to do any of my arithmetic out. I want to make sure I write down the problem appropriately the first time. Minus 4 times a is 1 times c is negative 20. And I'm going to be careful about this negative 20, and I'm going to put it in parentheses so I'm extra aware that there's a negative sign there. Divided by 2 times a, and a is 1. Okay. So now I know x equals this. I'll put a little equals x. So now my job is to evaluate this. We got to be careful. We got to start on the inside, and we deal with parentheses first. So what I recommend doing is pulling out a calculator for the parts that we need. So I'm going to simplify the square root part first. And I'm going to have 2 times 1 is 2. Negative 5 is just negative 5. But I need to do this math out. Well, 5 squared. I can do that in my head. I can go 5 times 5 is 25. And then it's negative 4 times 1 times negative 20. Negative 4 times 1 times negative 20. So I can, pull out my calculator. Negative 4 times 1 times negative 20. And I will get an answer of positive 80. Right? So this so far so good. Well, I'm still going to keep simplifying the inside. So I'm going to leave the 5 alone, plus or minus. 25 and 80 is 105 over 2. Now here comes the tricky part. I don't know the square root of 105. I mean, I could guess that it's a little bit more than 10. So I'm going to go over to my trusty calculator and type in 105, take the square root of that, and I get 10.2469. So I'm going to take that out to 3 decimal places. 10.247 is going to be my answer. 10.427. So negative 5 plus or minus 10.427 divided by 2. Right? Put my decimal there. All this is what x is. Okay, so I'm mostly done. I know now that this graph, the graph of this equation, has 2 zeros. One at negative 5 plus 10.427 divided by 2, and one at negative 5 minus 10.427 divided by 2. And again, I can approximate this. So I'm going to say that I'm going to do the first one. Negative 5 plus 10.427 over 2. Well, that's the same as 5.427 over 2. I pull out my trusty calculator. And I'm going to hit minus 5 equals, whoops, oh, I don't know what happened. Not so trusty anymore. Anyway, I get 5.427 divided by 2, and I can do that any number of ways. So I'm going to get 2.7135 is my answer. So approximately, x is approximately equal to that, or now I'm going to use the minus sign here. Negative 5 minus 10.427, all divided by 2. Negative 5 minus 10 is negative 15.427 over 2. Again, I pull out my calculator, I do my calculation, and I'm going to see that the answer is 7.7135, negative 0.71735 approximately is x. So those are my two answers. Okay? So that's one practice one. We're going to look at another one. And this one looks different, right? It's a quadratic, we can identify that, but doesn't look like this. And I don't even see 0. So what I want to do is set it equal to 0 and set it up like this so that I can use this equation. So I'm going to subtract 3x from both sides. And I'll get x squared minus 3x plus 4 equals 0. Note that I have my x squared, then my x, and then my constant term all written in a row. That's really important, otherwise this formula doesn't work. So I'm going to go through the same process. A is 1, B is negative 3, and C is positive 4. Negative 3 and positive 4. Then I start plugging into my equation, and I know that it is the opposite of B, so the opposite of negative 3. Well, we know that's positive 3, but I'm not going to simplify anything yet. Plus or minus the square root of b squared, so I'm going to be careful, and I'm going to put it like this, minus 4 times a times c, all divided by 2 times a. Okay. The opposite of negative 3, that's positive 3. So we get 3 plus or minus square root, negative 3 squared. Well, if you take a negative number and you square it, you get a positive. And I can do this in my head, and I get 9. And then I get negative 4 times 1 times 4. Well, that's negative 16. Divided by 2 times 1, that's 2. So some of this I can do in my head, and then I pull out the calculator for some of the other stuff. So then I go 9 minus 16. So I'm going to go 3 plus or minus the square root 9 minus 16. That's negative 7 over 2. Wait a second. I might know, or I might try to use my calculator to calculate the square root of negative 7. But I might know that the square root of a negative number is an imaginary number. So the answer does not exist. So there are no x's to find this. So x does not exist in the real number systems, right? So all these should have been equals x. And what we find is that it does not exist. And what this means is that we have some equation. I'm not even going to really draw where it is, but if this is my x-axis, this is concave up because that's positive. And it just does something like this. It just never intersects y equals 0. So there's no solution, and that's fine. That's fine. So I hope this helps, yeah, good luck. Thanks.